Hello students, I hope that you are doing well. Today we are going to continue the classes of grade 10 Science and Technology, and in today's class we will discuss about unit 9 heat, and mainly we will be concentrated in heat and temperature. Before it, about heat, you have done in junior classes. You know that what is heat, and you have done about different methods of transmission of heat like conduction, convection, radiation. Yes, do you remember them? Yes, they are what? Transmission of heat. So remember it, that heat is transmitted, because that point will be very useful in the coming concept about which we are going to discuss. Okay, so at first we will discuss about thermal energy, then heat energy, then temperature, and finally we will discuss about their effect, I can say effect of heat on the volume of bodies. But as usual, at first we are going to think about a question given here. The question is, why do we feel colder when come out from blanket at winter morning? I think you have remembered it. But the same room is experienced warmer when we come back after a short walk from outside. Do you remember this thing? Yes, same room we feel colder, and after some time we feel the same room as warmer. Why? What is the cause? Difficult? Okay. So that thing, that concept also will get in today's class. But now you should understand about it only that when we come out from blanket, body surface is warmer than the temperature of, I can say, warmer than the air of room. And at that condition, the heat from our body passes out to the air of the room. That means we lose heat and we feel colder. But when we go out and we walk some minutes outside, our body surface becomes colder. And when we come back in the same room, at that time our body surface is colder than the air of the room. That's why heat transmits from air to our body. And in that condition, we feel the same air, I can say same room, warmer. Yes, interesting? Okay, go ahead. Now we are going to do one activity, that is a group of activities. Again, we have to discuss about some events, discuss about the scientific reason of the precautions mentioned in the following diagrams. These diagrams are taken from your textbook. This activity is from your textbook. So first diagram you can see here, that is number of bottles are given here with different amount of water. A glass bottle full of water should not be kept in the deep fridge. Deep fridge means we do not place this water bottle completely filled with water in fridge to make it ice. That means to solidify it. What is the cause? Interesting, yes. If you do that, then what will happen? If you are using glass bottle, that will break, that will crack. And if it is plastic bottle, that also will be deformed in different shape, that will be changed. Yes. Why? That thing will come in today's lesson. So that is left. Okay, later we'll discuss. Next one is, a steel plate covering the cooking food should not be taken out using bare hands. Yes, yes, that will burn your hand. That's why we have to use some insulation. That's why we have to use some other tools to catch or to hold the lid, isn't it? Yes. So that is, heat transmits from one body to another body. That concept is given here. Hot water should not be poured into a glass tumbler during the winter season. Is it true? Not completely. But sometimes it happens that if you are using very cold glass tumbler and you are pouring very hot water in it, then the glass tumbler may crack. So to prevent that, it is better to keep the glass tumbler in lukewarm water before pouring it. Before pouring very hot water inside it, that saves your glass tumbler. Yes, that is also because of expansion of the body, and you can say irregular expansion. I think in junior classes you have studied about it. Yes. Last one is you don't care about that radiation, convection, conduction, these molecular motion, leave them. Just you have to answer that we should not put our hands over boiling water, not in boiling water, over boiling water also. Sometimes when we come in contact with fast moving steam, then you feel that how deep it burns. Yes, because that vapor can affect inside our skin, and this burning is very painful. Yes, so we should avoid the direct contact of steam on our body parts. Yes, that burns more deeply inside our body. Okay. So they are, all of them are related with, some are related with temperature, some are with heat, some are about heat transmission. Yes. Okay. Before starting today's main thing, we have to discuss once about molecular structure of a substance. Just I will recall only. Here the heading is molecules and molecular motion. So just you have to understand that molecules may be of elements and compounds both. In some cases, only atom is molecule. In some cases, two atoms form molecule. And in many cases, I can say in compounds, two or more elements combine, two or more atoms combine in a certain pattern and they form molecules. Anyway, substances are made of what? Molecules, yes. And these molecules are not still generally. They are always moving, and that motion is of three types. Vibrational, leave that arrangement, just understand vibrational motion, rotational motion, and translational motion. To make you understand that what are these motion, only that diagram is given. So this diagram is vibrational motion, means by keeping at mean point it vibrates. Maybe vibration in this way, like up one, maybe vibration like this way, maybe vibration like here less, here more, here less, here more, one side more, another side less, doesn't matter. Yes, but vibration is that particle comes again at its original position, that vibration. Okay, vibrational motion. And rotational motion is in this way, like in convection current. Yes. And what is translational motion? Translational motion is motion in a straight path. Linear motion. You have done in class 6, 7 about linear motion. Yes, that is also called as what? Translational motion. So here these three types of motions are found in these particles, in these molecules, which are responsible for thermal energy, responsible for heat energy, responsible for temperature, about which we will discuss today. Okay. So we should know that all the substances are made of atoms and molecules, and these molecules are not still, they are always in motion. Yes, there is only one temperature which is imaginary for the surface of the earth for natural condition, that is 0 Kelvin. You know what is the value of 0 Kelvin in degree Celsius? Minus 273 degrees Celsius. That temperature is naturally not found. Yes, artificially we can create. So consider, if a substance is at that temperature, then only its motion is stopped. Otherwise, substances move. And because substances have different types of motion, different types of energy, different amount of energy is produced from them. So we use average kinetic energy. You know that the product of motion is kinetic energy. Our kinetic energy is caused by motion of a body. So here motion is of different nature, different pattern, which gives different amount of energy. That's why we use what? Average kinetic energy for a particular out of these three. About that I will not tell now immediately, later you will find it. Okay. Okay students, at first you think about these two diagrams. Here one beaker is taken with more amount of water, another one with less amount of water. Both of them are being heated by applying equal amount of heat. Yes. So my question is that if they are heated by giving equal amount of heat, I can say at the same temperature they are heated, temperature if they are heated by given equal amount of heat, then which one of them will be boiled at first? That is the question. Yes. So you can guess very easily, that one or this one. Water boils faster in a big vessel or in a spoon? Yes, easily you can answer. So why it happened? It is because of different thermal energy. So what is thermal energy? On what factor does it depend? We will discuss in coming slides. Yeah. So here region is, here masses are different. Masses, more mass, here less mass. Average kinetic energy is also here different because of this region. Or you can say, don't discuss about average kinetic energy, just you concerned with amount of substance, or you can say number of molecules present in these two. They are different. Okay. Now, what is thermal energy then? Thermal energy can be understood by the analogy of ocean water. Consider it is raining. During rain, water is in motion. When it flows on ground, that is also in motion. And when it is collected in nearby ponds, nearby lakes, or say finally into ocean through the rivers. So in rivers, that is in motion, but in lake, in pond, in ocean, that becomes still. So you can compare thermal energy with water stored in lake, pond, ocean. But heat energy, rainwater, flowing water, that may be on ground, maybe in river, maybe in streams, anywhere, the flowing water. So in the same way, if thermal energy is flowing from one object to another object, that is not thermal energy. That is named by another thing, that is heat. And thermal energy is just remained or stored, or you can say the total kinetic energy which is not flowing from one object to another. That is thermal energy. Okay. The total kinetic energy of all the molecules of a body is called thermal energy of that body. Is it clear? If the same thermal energy is going to flow from one object to another object, then what amount of thermal energy is flowing from one object to other? That is called what? Heat energy. Later we will discuss in detail. Thermal energy is product of mass and average kinetic energy of the molecules. There are two factors which affect on what? Thermal energy. If any one or both of the factors increase, then thermal energy increases. Means if amount of mass is more, if average kinetic energy is more, average kinetic energy is temperature, and number of molecule is mass. So if any one of them or if both increase, then thermal energy also increases. Is it clear? Okay. Some more point. What is its SI unit? Thermal energy and heat have same unit. That is joule. SI unit is joule. You can measure in calorie also. But here main unit is what? SI unit is joule. And examples, what are the examples of it? They are geothermal energy, natural sources, geothermal energy, the heat energy found inside the earth, or solar energy. Solar energy, that is what? The energy given by the sun. Although that may change into heat. When it flows from one object to another object, that changes into what? Heat energy. So thermal energy is just that amount, I can say the total amount of kinetic energy found in a substance. Yes, that is what? Thermal energy. Now, about heat. This diagram was already used, similar diagram was used, and at that time I told you then don't care about radiation, conduction, convection, these processes. Yes. So here you have to now concern with them. Here radiation is a way of transmitting the total kinetic energy from this hot plate to surrounding. Yes. Here from this vessel to the handle, from handle to hand, and here from this vessel to air. Yes. And inside vessel also the particles are moving up and down. That means cold molecules are moving down and hot molecules are moving up. So that is showing what? Different method of transmission of what? Heat. Because the total kinetic energy is moving from one body to another body. So total kinetic energy moving from one object to another object is called as what? Heat especially. Yes? Okay. Now, here consider there are two bodies, body A and body B. They are at different temperature, and the red one having higher temperature than the blue one. Consider there are two objects, one of more temperature, another of less temperature. And if these two are kept in thermal contact means they are kept in such a way that heat can pass from one object to another object. So you know that from where to where the heat will transmit. Yes, that is shown by this arrow also. So heat will flow from what? More temperature to less temperature. That means from hotter object to colder object. Yes, that is heat. That is flow of thermal energy. Heat is flow of thermal energy. A different condition of thermal energy is considered as heat. That's why both are measured in the same unit. Yes, that's why both are measured by using the same instruments. Okay. Now next, here till when the heat will flow? Till both of the object have same temperature. Yes. So this thing can be understood by that diagram also. Here is hot body, here is cold body. Here molecular average kinetic energy is less, here average kinetic energy is more. And when they are in thermal contact, heat flows till the thermal equilibrium. So after thermal equilibrium means both have same temperature, both have same kinetic energy. So look here, it is not here, molecular vibration is not so big, not so less. So that is in between that. It shows that temperature of these two is something different, that is greater than it and lesser than it. So same thing happens here. Yes, it is more informative, and it is just we have to imagine something. Are you clear? So it is heat that flows from hotter body to colder body. Yes, not thermal energy. Yes, remember it. So the amount of thermal energy of a body that flows from hotter to colder bodies is called heat. Yes. Sometimes heat and thermal energy are used synonymously, but they are different fact. They are different fact. One is still, another one is in motion. Difference is that only. Yeah. Heat gives the sensation of warmth. Yes, heat gives the sensation of warmth. Thermal energy may not give the sensation of warmth, may give the sensation of cold also, because thermal energy is total kinetic energy, which may be more or less. But here heat energy is in flow condition, that means from hotter to colder. Yes, so that is also one difference. It causes change in temperature of a body. If a body is heated, temperature increases. If a body is cooled, temperature decreases. So it affects on what? Temperature of a body. Yes, so heat is cause and temperature is effect. Heat of a body is the product of mass, specific heat capacity, and change in temperature of that body. There are three factors of heat. How many factors were of thermal energy? Only two. Number of molecules and then average kinetic energy. In other words, mass and temperature. But here are three factors. What are they? One is mass. Next one is specific heat capacity, about which you will be taught later, don't worry. And third one is change in temperature of the body. Because when heat comes from one body to another, the another body changes its temperature. First body also, yes. So anyway, so what change is done, what change in temperature is done in the next body, that is determined by what? That is determined by amount of heat flown from hotter to colder body. Okay. Now, what is its SI unit? Joule. As I told you, it is also measured in what? Calorie. What is 1 joule heat? Or what is one? Oh, what is the relation of joule and calorie? 1 joule heat is 1 joule heat is 4 no sorry 1 joule 1 by 4.2 calorie, or 1 calorie heat is equal to 4.2 joule. So calorie is slightly bigger than the what? Joule. 1 calorie is 4.2 joule. Okay. Bigger than calorie, there is another unit also. What is it? That is kilocalorie. So you know the meaning of kilo. In first unit, you know that you have studied that kilo is 1000. So 1000 calorie equals 1000 kilocalorie. 1000 joule equals 1000 kilojoule. Yes? Okay. So after that, here next thing is, what instrument is used to measure what? What instrument is used to measure this heat? So here the instrument is shown. It is not perfect instrument like the thermometer. It is a group of number of apparatus that is called as calorimeter. Here is an insulation box that is usually made up of wood. Then one metallic vessel which is usually made up of copper. A copper stirrer. Stirrer means just like to move the liquid which is kept here inside the vessel. Yes. And here is thermometer and a lid which is heat resistant, or you can say it is of insulator. Yes. So this whole apparatus is used to measure heat, and it needs calculation also, for which we use heat equation. So about heat equation, its application will be taught later. Okay. Heat equation, indirectly I told you. Already I told you that what are the factors on which heat depend. So heat depends 3 factors, and all of the 3 factors are directly proportional. They are mass, specific heat capacity, and change in temperature. So here Q is amount of heat, M is mass, S is specific heat capacity, and DT is difference in temperature. In fact, globally, the trend of change of giving a symbol of specific heat capacity, C is used. So you do not confuse in these two. S and C are same thing. Yes. C is also used instead of S. In our context, S is used. But if you are seeing in international source, you will find C. So C is also specific heat capacity. We can use it also. Yes. So these 3 factors are in this relation that is called as equations, a heat equation, which will be used for what? Solution of numericals. Later we will discuss about it. Okay. Just formula you have to understand. Now some for one activity, here 2 diagrams are shown. Look here, what is shown here? Yes, glowing matchstick. What is it? Lukewarm water. It is bucket full of lukewarm water. Consider it is 20 liters. Yes. And it is just a small matchstick glowing. Which one has more heat? Can you guess? This one or this one? Just note down in your copy. Matchstick has more heat or lukewarm water has more heat? Okay. What is the question here? Which of glowing matchstick and a bucket of lukewarm water has more thermal energy? Here thermal energy you can say, because thermal energy in motion is called as heat. That's why I told heat. Yes, but thermal energy is more correct. So which one will have and why? Yes, if you are saying this one, you are incorrect. If you are saying this one, you are correct. Why? Because here average kinetic energy of molecule is more, here less, but number of molecules are very less here relative to that. Here is huge amount of number of molecule. So the total kinetic energy becomes here more. Mass into temperature, amount of substance into average kinetic energy is more here and here is less due to less mass. Okay. And which of glowing, so answer you have got, which one has more temperature? Yes, that is absolutely matchstick. It may burn you. Yes, because it has more temperature. It may not burn. Lukewarm. Yes, so that has less temperature. Average kinetic energy is more here and less there. Okay, by another example also, you try to understand thermal energy and thermal energy and temperature. So here you are given a kettle in which tea is cooked. All of the ingredients are kept here, whatever is required to cook tea. Everything is kept there, including sugar. And then a cup is poured here. If you are testing, just taking a sip from cup, and then from kettle also 1 spoonful take out and then sip, which one will be sweeter? Which one will be experience sweeter? Sweeter means not taste, I mean that gulio. Yes, sweetness. Which one will have more sweetness? Both same. Yes. But if you are drying the water of this cup and the water of this kettle, from where you can get more sugar? Sure, from this one, because there is more amount of water and sugar and here is less amount of water and sugar. Yes. In the same way, if you are measuring these two, that means the temperature you are measuring by using thermometer, then here the temperature will be found less and here will be more. Am I correct? No. Both have same temperature. Both same temperature. If you are neglecting what? The temperature lost in that vessel, neglect it, then both will have same temperature as they have same sweetness. Yes. And what will be the amount of heat? If both of them kept to cool, which one will be cool faster? Yes, absolutely that one, cup one. Yes. You know that in our daily life, which one is cooled? The food in your plate or the food in cooker? Which gets cooled faster? In our plate, yes, because there is less amount of heat. So here is less amount of heat, here is more amount of heat. Because average kinetic energy is same in both, but total number of what? Molecules are different. So heat, you can say, in fact, thermal energy, because here it is presented in the form of not flowing from one place to another. Yes, so that is thermal energy. So look here, consider tea is cooked in the kettle with all the ingredients required. The tea is poured in a cup and temperature of both of them is measured immediately. So temperature is measured, you found that temperature same. If the tea is sipped using a spoon one by one from each of the vessels, which of them will have more sweetness? Same. Yes. Okay. Consider you are getting amount of sugar dissolved in each of them by evaporating. From which vessel will you get more amount of sugar? Already we discussed. So here compare the temperature with the sweetness and amount of sugar with thermal energy. You will be clear in thermal energy and what? Temperature. By this example also, that is also very interesting example, and from your daily life it is taken. Okay. What is temperature then? Now look, temperature. About temperature we have finished indirectly. Average kinetic energy of molecules contained in a body is called as temperature. Yes, it is not related with total kinetic energy. So this average kinetic energy does not transfer from one place to another. Yes, heat transfers and that changes the temperature. So temperature is what? Later it is coming. Yes, I am not saying now immediately. Degree of hotness or coldness of a body. What is temperature? Degree of hotness or coldness. Yes. And it determines the flow of heat. It does not flow from one body to another body, but it determines that the direction of heat flow, because the heat flows from hotter body to colder body. That's why the flow of heat is determined by what? By temperature, from more temperature to less temperature. Temperature is effect of heat, about which I told that I am not saying immediately, that has come. Heat is cause and temperature is effect. Yes. What is unit? There are different units of heat. SI unit is Kelvin and other units are degree Celsius, degree Fahrenheit. One British system is also there, Reamer scale is also used, that is not so much used. Yes. So, they are some what? Units, and here it is measured by using thermometer, about which you are familiar. Now, students, you are given one table in which you have to compare thermal energy, heat and temperature. Write in short only, not in detail. Okay. Now, see what have I written. Thermal energy, total kinetic and potential energy of molecules. Here potential energy also used, that is very good, complete definition. Measure of the energy transferred from a warm to colder one. And what is temperature? Measure of the average kinetic energy of the molecules. Yes. Next, what are units of thermal energy? Joule and calorie, heat, joule and calorie, but temperature, degree Celsius, degree Fahrenheit, Kelvin and Reamer. Next, thermal energy varies with mass and temperature. Heat varies with three factors. Already you have discussed mass, temperature and specific heat capacity. And temperature does not vary from, that means substance to substance. Next one, measured by using calorimeter. It is also by calorimeter, but thermometer is used for temperature. And last point, cause of heat and temperature is thermal energy. And here it is cause of temperature and temperature is effect of heat. Okay. So, they are some comparative study of these three major things. After that, we are going to do some practical activities. Okay. I have fitted the balloon in this bottle. Now, what will happen about its volume when I will pour hot water on it? Just see here. Okay. Now, see it. Yes. Why? It is very hot. That's why I cannot hear. That is very hot. You can see more. Yes. So, what change you have found? Why does it happen? Yes, because air inside the vessel is expanded and here its volume is increased. That's why the balloon is inflated. Yes, interesting. I think this experiment you have done in junior classes also. So, it proves that when air is heated, it expands. About expansion of water is expansion of liquid you have experienced in kitchens. When a vessel full of water is heated, then what happens? Spills out. That shows that proves that liquids also expand by heat. About gas, we have already finished. Here molecules were very close, but here farther. That's why the balloon is inflated. Yes. Next one, water. Here I have not done this experiment because it is seen in our daily life. We see it. We know that when substances are liquid is heated, it expands. And next one is here about Gravesend ring. Here Gravesend ring is a ball and a ring. The ball is just fitted in the ring. It can pass easily when it is not heated. But when it is heated, then what happens? It does not pass through it. So, same thing, same concept is given by this apparatus also. What happens in them? You can see by this diagram. Here is vibration in solid in this way. Yes. So, if the solid is heated, vibration range increases. In liquid also there is motion of molecules, but by vibrating more. That's why, and here the area you can say volume, the surface, the area around the molecules increases and it increases what? Volume. Yes. So, solid, liquid, gas, all of them expand when they are heated. That is due to their what? More vibration. Yes. Okay. Now, I am going to give you one project work, that is very simple project work. Make a list of events of our daily life that are based thermal expansion. that are based on thermal expansion. Yes, okay, that show thermal expansion. Now some questions are here. I am going to find out that whatever you have learnt. That is, first one, which of following is temperature? Here you have to just mark the correct one. A, total kinetic energy of the molecule contained in a body. B, average kinetic energy of the molecule contained in a body. C, total kinetic energy of molecules that flows from a body. Average kinetic energy of molecules that flows from a body is D. So out of them, temperature related with average, leave total. Out of these two average, which one? That one or that one? So very easily you can find out that is what? B. B is correct one. Now next question, which of following is unit of thermal energy? Joule, Kelvin, degree centigrade or degree Fahrenheit? So only one is of heat and thermal energy both, that is what? Joule. Next one, which of following instrument contains metallic vessel, thermometer, stirrer and insulation box? Infrared thermometer, digital thermometer, calorimeter or manometer? So yes, you are correct, that is calorimeter. Now next question is little bit more you have to think. Which statement of following is true? Heat is total kinetic energy of molecule, but temperature is average kinetic energy of molecule of the body. Or thermal energy is total kinetic energy of molecules, but temperature is average kinetic energy of molecules of the body. Slightly different. Find out. Next, temperature is total kinetic energy of molecules, but heat is average kinetic energy of molecules of the body. Or temperature is total kinetic energy of molecules, but thermal energy is average kinetic energy of molecules of the body. You guessed? Yes, not guess. You have to find out. Yes, one by one. That is B number. Thermal energy is total kinetic energy of molecules, but temperature is average kinetic energy of molecules of the body. Okay, here are some questions to which you have to copy in your copy. You have to copy in your exercise book and then answer. This answer you have to show your teacher. First one is define heat and temperature. Easily you can do. Second one, differentiate heat and thermal energy in 2 points. Only 2 points you have to give. Next one, write any 4 differences between heat and temperature. Yes, I think you can do it. Describe the cause of thermal expansion of bodies. Here you have to add of cause of thermal expansion of bodies. Next one, give scientific reasons of following. What are they? First one, heat can flow from hotter to colder bodies, but temperature cannot. Next one, thermal energy of a body is influenced by mass of the body, but temperature is not, or temperature does not. Next one, a metallic wire tied between 2 poles tightens in winter but loosens in summer. Relate it with your activity. You can do it. Okay students, today we have discussed about thermal energy, which is total kinetic energy of molecules. Then we discussed about heat. Heat is total kinetic energy that can flow from one body to another. Then we discussed about temperature, which is average kinetic energy. Yes, so all of them are related with kinetic energy, some total kinetic energy, some average. Yes, and then we found that what is the effect of heat on the volume of bodies, which is called as thermal expansion. Okay, thank you for today's class. Next time we will come with some more topics. That's all for today. Namaste.